Theory and Systems Architecture, a thread presentation. Courses from System Architecture thread. One of the courses required for Systems Architecture thread is ECE 2031, Digital Design Laboratory. The goal of this class is to design and implement digital systems. This is accomplished through CAD tools, project design methodologies, logic synthesis, and assembly language. The goals of this and main objectives are basically to apply knowledge gained from CS 2100, apply basic combinatorial logic, sequential circuits, and programmable logic in a lab setting, and develop familiarity and confidence in building digital circuits along with developing team building. The team building is functionalized by using groups of 3 to 5 students to complete projects together. Technical writing skills are also developed through laboratory, through reports, project documentation, and an oral presentation. CS 4210, Advanced Operating Systems, is one of the choices you get for your systems architectural thread. This class covers operating systems, abstractions, and their implementations. The central themes of this class are concurrent programming, threads and synchronizations, inter-address communications, and distributing operating systems. This class is broken down into 2 tests and 3 main projects. The first project is creating a web server, the second project is creating a web proxy server, and the third is creating a distributed proxy server. This class is mostly programmed in Unix and C. CS 3300, Intro to Software Engineering, is another one of the courses that you get to pick for Systems Architecture thread. This course' main goal is to promote team-based projects to apply software engineering principles. This uses multiple different development processes such as RUP, TSP, TDD, and Agile. Class grade is split between a group project and individual assignments. Specific details of the projects are determined by class basis, but it gives a little bit more freedoms to the groups compared to classes like CS 2340 and gives more room for individuality and growth.
CS 4540, Advanced Algorithms. This is one of the required courses for the theory thread. In this class, students will learn advanced techniques for designing and analyzing efficient algorithms for combinatorial problems and see their applications to computer science. Main topics include fundamental algorithmic paradigms, approximation algorithms, and randomized algorithms. Students will also submit either a term paper or project presentation involving these algorithms. Math 4150, Introduction to Number Theory. This class is one of the advanced mathematics picks for the theory thread. In this class, students will learn factorizations, congruences, theorems, equations, approximations, and quadratic reciprocity. They will also see applications such as fast multiplication, factorization, and encryption. Eventually, students will learn how to understand and use these various numerical methods and use them in the analysis of algorithms. CS 4400, Introduction to Database Systems. This course is one of the elective options for the theory thread that involve algorithms and complexity. In this class, students will learn how to use, design, and make their own databases. The database style that they learn is the relational model. The signature project for this course is making an actual database. Students will model the information needed to make the database and then use the hardware and software provided to make it. Students might use Java, PHP, Python, or SQL in the making of this project.
Faculty for the Systems Architecture thread. Bob Waters is a professor here at Georgia Tech. His bachelor's from CS he received from Murray State University and got his master's and PhD from Georgia Tech. His dissertation was on the recovery of software architecture from legacy systems using concepts analysis. Professor Waters previously worked at Force Command headquarters in Atlanta until coming to Georgia Tech. He has taught CS 1332, CS 2335, CS 2340, CS 3511, CS 3911, and CS 4320. Another systems architecture professor here at Georgia Tech is Thomas Conte. He received his bachelor's in electrical engineering from the University of Delaware and received his master's and PhD in electrical engineering from the University of Illinois. He previously taught at UNC and NC State before coming to Georgia Tech. His research in the area of computer architecture and compiler optimization. He works with computer science, computer engineering, and electrical engineering, realizing that computers are the way of the future.
Monica Sweat attended the University of Florida, where she got her master's in computer science, as well as her degree of engineer. She was recently appointed to the position of Director of the Division of Computing Instruction. She's also a senior lecturer in the same division. Alayna Mihail. When Dr. Mihail was first trying to figure out what she wanted to do, she asked herself, where do all the quote-unquote smart people go? At the time, most of the smart people were going to study electrical engineering, so that's where she went. Towards the end of her studies for electrical engineering, she saw a shift from electrical engineering to computer science. And since she wanted to be a part of that, after she got her diploma in electrical engineering, she went to Harvard University, where she got her PhD in computer science. Currently, she is an associate professor at the College of Computing. Her research interests include theory and networking. Heterogeneous platforms and systems is the core of our research. Heterogeneous computing is using more than one type of processor or core in a system or platform in order to increase productivity or energy efficiency. This project involves looking at and using the advantages of heterogeneity, as well as dealing with the problems it comes with.
Another research option is Tinkers, which is led by the previous member Tom Conte. The Tinkers project creates new technology for high-performance computing by breaking down the traditional layers of abstraction between the hardware, microarchitecture, instruction set, compiler, and operating system. The Tinkers group has written multiple publications, which include and are not limited to memory system design for ultra-low power, computationally error-resilient processor microarchitectures, superstride associated array architecture, and superstride associated array architecture.
Master of Science in Cybersecurity, Information Security track. This is one of 3 tracks for the master's degree in cybersecurity. It has been managed by the School of Computing since the 1990s and examines security principles and emerging techniques for software, computer systems, and networks. Special Agent FBI. While the FBI encourages many people of many different backgrounds to apply, they are specifically looking for people with skills in STEM backgrounds, such as encryption, data science, cybersecurity, and many other STEM backgrounds. Other requirements include being at least 23 but no older than 37 when applying, having at least 3 years of work experience in your field, passing a physical fitness test, as well as going through a very extensive interview process.
One career choice for a thread and system architecture combination is a system engineer / site reliability engineer for Google. Their responsibilities include engaging in the improvement of the whole life cycle of services, from inception and design through deployment, maintaining services, and scaling the system all the way up. This is a great fit for system architecture and theory. For one, the theory side could be a great fit to help finding optimizations of the system as a whole. And the system architecture on the other side could help design and implement closer to the basics levels of computing. And I'd like to thank you again for your time in considering our great thread combination, theory and system architecture.